Hey guys, today we're doing Chapter 11, Section 1. So we're just starting out Chapter 11 in Advanced Algebra, and this whole chapter is on polynomial functions. So Section 1 is just kind of an introduction to what polynomial functions are, and then we'll start talking about different things that we can do with polynomial functions. So the first thing we want to do is look at the definition. So what is a polynomial? Well, a polynomial in x is an expression of the form a sub n x to the n plus a sub n minus 1 x to the n minus 1, etc., all the way down to a sub 0. So essentially what this is a sub n and a sub n minus 1 and a sub n minus 2. Those are just the coefficients of your values. And then we've got x to the n minus 1, x to the n minus 2. So that'd be like x cubed, x squared, x to the 1, etc. So essentially we just have a bunch of powers being added together here with coefficients. So it says where n is a positive integer and a sub n is equal to 0. Oh, not equal to 0. So your first leading coefficient cannot be equal to 0. Alright, if we want to find the degree of a polynomial, that's just the largest exponent of the variable. So in your function, whatever highest power you have, that's the overall degree of the polynomial. A 0 degree means that you have some sort of non-zero constant, so 3 or 5 or 100. If that's your entire polynomial, then you have a degree of 0. A first degree is a linear polynomial, so that'd be something like 3x plus 5, where you just have your highest power is an x value, not taken to any power. Okay, second degree are quadratic polynomials, and third degree are cubic polynomials. So your terms, those are actually the values that you're just adding together. So if I had something like 3x squared plus 5x plus 8, 3x squared would be one term, 5x would be one term, and 8 would be one term. So the terms are just the different things that we're multiplying together in our polynomial function. Standard form is when you write the terms in descending order by degree. So for example, 3x squared plus 2x, that would be in standard form because x squared is larger than 2x, so I'm writing it in descending order. Whereas something like x plus 3x squared plus 5x cubed would not be in standard form because I was starting with the smallest one and going towards the largest one. Okay, if a polynomial is given, we want to write the polynomial in standard form, give the degree of the polynomial, and name the leading coefficient for each of these problems. So for the first one, m to the 4th minus 3m to the 7th. First thing I want to do is write the polynomial in standard form. Remember, that means that I need to have it in descending order for my powers. So I want the biggest power first. So I'm going to start with this negative 3m to the 7th, and then I'm going to add m to the 4th, and now I've written it in standard form. For part B, I want to give the degree of the polynomial. So remember, the degree is the highest power that I have overall. So looking at this, my highest power is 7, so the degree of my polynomial is 7. And for part C, I want to name the leading coefficient. The leading coefficient is just the coefficient of your largest power. So here, my largest power is m to the 7th, so the leading coefficient of that term would be negative 3. Alright, I'm going to do the next one. So 4n minus 15 minus 3n squared. First thing I'm going to do is write it in standard form, so that's negative 3n squared plus 4n minus 15. Part B, I want the degree of the polynomial. In this case, squared is the largest, so my degree is 2. And then I want the leading coefficient. So in this case, n squared is my largest value. The leading coefficient of that is negative 3. Alright, next up I've got 8p squared minus 1. So if I want to write that in standard form, it already is in standard form. Part B, I want the highest power, so the degree of the function is 2. And for part C, I want my leading coefficient. In this case, it would be 8. So there's also an example in your book on page 676. If you look through that example, that will kind of give you an idea of some other types of problems that you might see. And that is everything.